Today we're going to look at section 5.2, day 2, and we start off with what appears to be a review, but it's a very, very important set of things to memorize. It's the graphs of sine and cosine. What you want to do is always keep in your head that the graph of sine all by itself with no extra shifts, transformations applied in, starts in the middle, goes up to a height of 1, down to -1, and repeats itself at 360 degrees, which we'll rarely say again, at 2 pi. The graph of cosine, kind of like a cousin to sine, starts up high, starts at 1, goes down to -1, and then also repeats itself at a value of 2 pi. When you keep these graphs in mind, what happens is anytime you have to do transformations like we did in the previous day, it's very easy to apply because we've been learning these since the start of the course. But also, memorizing these graphs, when you do it hand in hand with the unit circle, they actually are a very, very powerful tool to find exact values in a further course in math. So with that said, what we're going to do today is have a very short lesson on what if you were asked to work backwards. Here's where my neatness lets me down and you down a little bit. What we need to do is look at a very neat graph. Thankfully, the textbook and the sheets that you'd already received will have neatly typed graphs with technology. But here's the name of the game. What we are looking to do today is take a peek at a graph. That would have to be, again, very, very exact. So the one that's in the PDF notes and the one that I attempted to replicate here is the graph of a sine equation that starts in the middle. Okay, if you guys just take a look, the middle of the graph is right here. That's why I keep saying it starts in the middle. It starts at a height of 3, goes up to 5, down to 1, and then repeats itself at a value of pi. Now here is what you'll be doing today. What we will be doing is we'll be trying to say, well, could we write an equation that satisfies this graph that would be a possible equation? Now, I'll address the word possible in just a moment. So what we are going to do is not play around. We'll just say it's a sine graph. It does resemble a sine graph that's been shifted somehow. So what I am going to do is I'm going to go sine, and then you can use either an x or a theta. In the notes, the PDF notes, there's a theta. I'll use an x just to show you guys it doesn't really matter. Now, what we are attempting to do is to say, well, what would be the values? Now, here's how we begin. Normally, sine goes up to a height of 1 and down to -1. Well, this one, notice how instead of going just 1 up and 1 down, like in the original graph, it goes 2 up and 2 down. What would happen is then the amplitude changes from a value of 1, it changes to a value of 2. So it's pretty easy to find out what the amplitude is. This was the A position. Now, I'm not going to do it in the order that we're going to write it down in. What I'm going to do is get to the next easiest one, and that would be the shift. And then you start to see where a few of my things came in. Normally, the middle of the graph is at a height of 0. If you guys take a look, the middle of the graph, where we started writing the sine equation, is at a height of 3. And then all of a sudden, you'll realize, oh, this was shifted vertically, up and down, a positive 3. It was shifted up. It's not too hard to make that connection. Now, here's your final one that requires maybe just a smidgen of thought. The first two, most people don't panic on. It would be, should there be a number here? Well, yeah, because that's why I left a space. But then the question is what? Normally, sine and cosine repeat themselves after 2 pi, 360 degrees. Well, there would be a 1 there. Now, this one doesn't. This one repeats itself at pi. So the period of this is a pi. Now, why did I write it like this? Here's the idea. Period is always 2 pi divided by some number. That's a question mark. That's the number that goes right here, the question mark. What number would that have to be? Well, now once you see it, if we need a period of pi, that's how long this was to repeat itself. That was the given question. Now this is our answer. Well, what should go in the question mark is a 2. Then the 2's cancel out, and now I have my final answer. This would be an equation that satisfies this graph. Now, I'm going to move to the possible. This isn't it. When we are moving horizontally, think the old wall window. This could easily have been, and don't panic, you will not be tricked in this. This could easily have been a cosine graph. Just watch. If I erase a little bit up here and then here, it does resemble a cosine graph that's been shifted up and maybe moved wall or window, whichever it's supposed to be, and then it would be a cosine. It will not be your job to try to figure that out. Is it sine or cosine? We are told which it is, but the idea is this graph could resemble more than just the basic sine graph. Now, When you were doing the PDF version of the notes and you're looking through them, what I referenced was the sheets that you were given at the start of the chapter. And when you go, it'll say page 73 on the sheets. What we did was we did the same idea, writing an equation from given values, but instead of taking a look at a graph and then trying to read the graph, what we did in the sheet is we said, what if we were given these clues? The period is 2 pi and the amplitude is equal to 4. What could the equation be? And we were told to write it either sine or cosine. I believe on the sheet it told us to write sine. Well, here's how you could do it. If you were supposed to have an amplitude of 4, all we need is a 4 in front. That gives us our amplitude. It is done. And then we can put an x or a theta, and we're actually done the question. Because when we don't have a number in this position, it's called the B position, the period just naturally comes out at 2 pi, just like it should. Now I'll do just one more, and then you can look at the final one on your own. In number 26, again, it asks us to find a sine equation that would have a period equal to just 1 pi, an amplitude equal to 1/2, and then this thing called a phase shift. And you will read it more and more in the notes. That is an old school name for the horizontal shift, the wall in the window. I know you're thinking, well, why do we need to know that? Well, there's more than one way to say it, and we have to be kind of used to all of them. Just think back to the old days, add these numbers together, find the sum. Well, there's two different ways, and you kind of needed to know both when you were quite young. So here's how this guy unfolds. Let's just start working left to right. It says to do a sine equation, and it says the amplitude is 1/2. So all we simply need to do is to put 1/2 in front. Now we go to the B position. We are supposed to get a period of just 1 pi. Now this should feel familiar. Period is normally 2 pi divided by some number, and we're supposed to just get a pi. Well, just like before, it was a 2. So if we put a 2 here, we do satisfy the period that we're supposed to get. Now what about this phase shift, the horizontal translation, the wall window that we keep referring to? We are supposed to move it, pi. And so that was what would go into the bracket. In the bracket, if we are supposed to move it pi, and it will be very exact. If you read the notes, it tells you whether we're supposed to go left or right. Imagine we were supposed to go to the wall, well then it would be a minus. If it was the window, well then it would be a plus. I'm going to leave 27 for you guys to look at. And this is, I guess, working backwards, where you're given the information, either a graph or the details, and you're asked to find an equation.